So, why are people choosing the number 37 when it comes to random numbers, choosing the number 37 more often than choosing other numbers? This is one of the craziest questions and topics right now. Like, what is up with this 37 deal? And I ran across this video. Let's check it out and see what he says, and everything, and have a critical review about it, basically.
Let me show you something unbelievable. Name a random number between 1 and 100.
61.
Okay, that's pretty random.
Let's name a random number from 1 to 100. Random.
43.
43. Thank you so much.
56.
7.
Hold up, before we go any further, let's talk about this question I got from a viewer in my comments section on one of the last videos. He asked me, do I smoke cigarettes? Okay, first thing, I don't smoke cigarettes, but I still get the nicotine from them. All right, what I do is I have my lighter and my cigarette, and I light up the cigarette, like a normal person would do, and then I eat the ashes. I don't smoke it or nothing like that. I just eat the ashes. That way I still get my nicotine intake. You know what I mean? But, yeah. Oh, I'm just joking. I don't smoke cigarettes.
I want the most random number between 1 and 100, like totally random.
11.
37.
79.
79. Thank you so much.
91. 7.
3.
37.
37? Why 37?
Wow, that was strange there for a second. Okay, one of them guessed 7 and the other one guessed 3. So that combined would have made 37, right? And it's crazy because the one on the right was 7 and the one on the left was 3. So it would have definitely combined for 37. How crazy is that?
7.
Oh, it's just the first number that came from 1. 44. 27.
37. 72.
4. 13.
7. 37.
Really?
59. Merci.
That is just really strange, y'all.
13.
7.
37.
37.
73.
37.
35. 37.
37. No way.
43.
2. 37.
Okay. Are these people being paid off for this or what? What's going on here? Because how would that many people be guessing 37, y'all? Think about it like that. I mean, yes, 3 is a odd number, to pick for sure. Out of 1 through 9, 3 is definitely an odd one. And 7 is definitely also what I would call an odd one also, because 7. I mean, how random is 7? You know what I mean? But why are all of these people picking 37? That is one interesting thing. I'm serious. That is interesting.
I knew you were going to do it. You just 37 and walked away.
Between 1 and 100. Okay.
37.
Oh, perfect. Thank you so much.
83. 37.
37.
87.
55. 37. 37.
Okay.
Can I shake your hand?
I love the thought you're putting into.
What is going on with this many people choosing to pick 37 over all the different random numbers that they could already pick? They could pick 1 to 100, and most of them are picking 37. You gotta be kidding me. What is up with that? Why do some people have 37 already down as what they would pick for their random number?
37?
No, you are kidding me. What? Are you real?
What?
Did we ask you this already?
No.
Random.
Bro, are these people getting paid off to say 37? Or is this a real thing? Like, I hope they really break it down and so we could understand this a little bit better, right? Because why would that many people choose a number that is that random?
Random number between 1 to 100.
37.
37. Oh my gosh. Yes.
Name a random number between 1 and 100.
I thought he said 36 at first. I thought he said 36. But he said freaking 37. If this dude say 37, bro, ain't no way this dude about to say 37.
37.
Are you kidding me? Why?
It's a good number, I guess.
it's a good number. He get what? How is 37 a good number, y'all? Tell me in the comments if you think 37 is a good number. I mean, I guess 37 an hour in pay would be pretty freaking cool, right? Pretty freaking good. But 37. Why is it such a great number to pick from? I'm so confused at this point right now. You know, where were we? What were we doing? Talking about 37? Oh yeah. Why is that better than 26? Why is that? Why is that better than 91? You know?
Number? Where did that come from?
Imagination, I suppose.
So, what's going on? Well, people are actually really bad at selecting things randomly. In fact, when asked to pick a color and a number, people reliably select blue and 7 the most across.
Wow. Okay. To say, 7, what this is showing us right here is that, okay, they got 3 out of 4 that really go with 7, right? And, well, actually, they got 4 out of 4 that go with 7. Hold up here. Okay, no, I had that wrong. My bad. But how crazy is this, y'all? Look at that. All these different countries say blue and 7 as their main numbers. Yeah, I don't understand that, bro. That's crazy.
Dozens of different cultures. Psychologists have a name for this pattern, the blue 7 phenomenon. And when picking a random number between 1 and 100, it has long been suggested that the equivalent of the blue 7 phenomenon is the number 37. My producer Emily and I spoke to hundreds of people to test this theory. The most common answer was 7, but maybe that's because people just expected that we'd ask them for numbers between 1 and 10.
Look at this chart real quick. So you see that 37, right? If you're looking at the chart, that 37 on the chart is way up there. Almost as high as 7. Almost. So it must have got around 12 37s on that spot, because it says respondents, so 5, 10, 15. So it looks like it got about 12 respondents of people that said 37. Wow. I mean, that is really crazy, but it looks like 7, that one got over like 16, you would say, or 17. I would go with 16 respondents. All right, and the other one got 12, 37. So 7 got 16 respondents, and the other one got 12, 37. I mean, that's pretty close though, and 7 is still really close to 37. Still.
The most common 2-digit number really was 37, much to our surprise.
Strange.
So we decided to
Let me know in the comments, do y'all think some of those people were maybe paid off to say 37? Or is this a real phenomenon that I'm just not sure exists? Is this something that is for real? Like, how can I understand this better? Let's find out. Hold on.
embark on the biggest investigation ever on the number 37. And it took us to some unexpected places.
I think 37 is a fascinating number. It's just really interesting because it turns up so much. I think
37. And it took us to...
Hold up here. So you telling me these stars right here line up to be 37? In a system, boy, it look like a star system that say 37. How crazy is that?
To some unexpected places.
I think 37 is a fascinating number. It's just really interesting because it turns up so much. How many objects are there here in the room with us that have a 37 on them? I'm sure there's more than 1,000 here. I built the 37 website in 1994. I started getting email from strangers. It's everywhere. I'm trying to collect them all.
What would even a 37 online thing even be a business about? How can you name your business 37? Like, why would anybody? I guess it'd be a smart idea to name your business a number that low, though, probably. But I don't know. It doesn't seem like such a smart idea to name your business a number, right? Like if you name your business number 37. Think about it. How is anybody supposed to know what your business is even about when your business is already just a number? It don't make no sense.
Tireless. The tireless cabal of 37 people. Yeah.
Apparently, people choose 37 so reliably that there's even a widespread professional magic trick that relies entirely on getting an audience member to just pick 37 out of thin air. It's called the 37 force.
I'm going to ask you to think of a number in a moment, okay? It's a 2-digit number. It's less than 50. Both numbers are odd but different. You could have 19, 17, or 15, but not 11, because you see both numbers are the same, 1 and 1, next to one another. Are you ready? 1, 2, and 3. What number did you think of? 37. Fascinating.
That's strange. So you telling me the whole crowd done picked 37?
In the famous Stanford MIT jargon file, The Origin of Hacker Slang, 37 is given as the random number of choice for computer programmers. When groups of people are polled to pick a random number between 1 and 100, the most commonly chosen number is 37. The thing is, no formal polls on this actually exist. The best we found was a Reddit poll of 1,300.
Now we everybody need to get down and ask everybody a random number and see if somebody tell you 37. Boy, the minute that you hear 37, you would be like, this is for real. If you ever heard 37, whenever you ask somebody that, you are going to be like, oh my goodness, this is a real phenomenon. This might be one of them real things going on. A number 37, maybe it could be something that's really good. 37,
80 people from 4 years ago. And the most popular number was 69. But after that, the winning number was 37. But we can do better than...
Well, I'm not too surprised about, the other number for sure at all. But 37 is just really strange because you don't hear that much growing up. You don't hear about number 37 that much growing up. So why would these random people just randomly select 37,
Than a sample size of just 1,000 people. So we conducted the largest random number survey ever. In a community post 3 weeks ago, we asked people to pick a random number between 1 and 100. We received 200,000 responses.
Oh, snap.
Here are the results as they came in.
So 37 at this point, okay, at this point, it has 4,256 respondents. All right, at this point, 37 is lower than the people that picked like 42. So it's lower than 42 at that point. But, it's looking like he did it over time. So it's maybe they have even more. Let's find out.
Fascinating to watch how consistent these supposedly random numbers are, from 10,000 to 100,000, all the way up to 200,000 respondents. The distribution barely changes, suggesting that people...
So, okay, I thought 37 was fixing to blast off the charts. Hold up.
Were 73 and 37. Ironically,
so that is strange, right? That a lot of people are choosing to pick 37 and 73 and, or 73 and 37, depending on how you look at it. But I think it's crazy because those numbers are very much alike. If you flip them around, one becomes 73 and the other one becomes 37, right? If you flip them. But, I mean, what is so significant about these numbers that people are picking them that we just do not understand yet?
All this evidence points to 37 and its inversion, 73, as not being random at all. So why does everyone pick them? Well, one argument is that this is just how people perceive randomness. 37. Does that feel random to you?
Yeah. Yeah, it does.
See, if somebody said pick a number 1 to 10, 1 to 10, all right? You know, if you have to pick the most random number you could think of from 1 to 10, what number you picking, chat? Because, you know, they might be on to something here. Because now that I'm thinking about it, if somebody asks me, you know, pick a number 1 to 10, most random, I'd probably go with 3. And if I would not go with 3, I would probably go with 7. Because they are odd numbers.
Yeah, 50 wouldn't be random.
No. It would be too contrived.
Yeah.
Yeah, it's too simple.
I think people think that even numbers are less random than odd numbers.
5 feels not random. 9 and 1 feel too extreme, so people tend towards 3 and 7.
This is backed up by the fact that every one of the top numbers in our survey consisted of 3s and 7s. In fact, 3 and 7 were the most selected digits on both questions.
Dang.
But there's also a mathematical case for humanity's number of choice, because it's not just odd numbers, but specifically primes which feel like the most random numbers. Notice how we ignore odds ending in 5s, or how something like 39 still feels a little less random than 37. Primes feel random for at least...
Does 39 feel more random than 37? Let's talk about that real quick, chat. Hold up here. 39 or 37? If someone asked you to pick a most random number between 39 and 37, which one you going with? I would probably pick 37. Because 39, you know, unless we talking about money, you obviously rather 39. But we ain't talking about money. We talking about why these people are picking these random numbers with 37 and 73 and all this. That's what we talking about right now. You know, it ain't got nothing to do with no money.
2 reasons. First, they don't appear as much in our lives. I mean, pixel counts, fruit boxes, square footage. We live in a composite world with multiple dimensions that multiply together. So we just don't see primes much past the single digits. Second, we don't have a formula for primes. If you have a prime number and you want to find the next one, you have no choice but to check every number until you find a prime. The closest thing we have to a formula is the prime number theorem, which gives the approximation that the nth prime number occurs around n times natural.
Oh, man. Dang. Oh, no. Here we go again.
Log of n.
Hold up.
For example, the
Here we go again with this NLN slash N slash. I mean, come on, bro. No one is going to understand that, right? No one is going to be able to understand what them NLN mean, right? Ain't no NL mean. Like, what does that even mean? Okay, we understand prime numbers and we understand the bottom numbers, right? Kind of similar, but they're not similar. The bottom numbers, they're different from the left numbers. But what's up with this NLN? Anybody want to share? Anybody know what's up with that?
1000th prime number should be around 6,908, and it's close, but certainly not exact. So primes essentially occur at random. But of all the primes, 37 has reason to stand out. Occurs around n times natural log of n, For example, the 1000th prime number should be around 6,908, and it's close.
So, you see, this is not really simply breaking down to us by showing us the 1000 prime number and stuff like that. Why not just show us from where the prime numbers start going up? Like, you know, start at the very first prime number, which would probably be 3 or 7, right? And show us the numbers going. Why start in the thousands? Why start prime numbers in the thousands? Okay. You know, prime numbers probably, if you wanted to simplify it and break it down real simple, why would you not just start showing everybody the prime numbers by 3 and 7, and then, you know, 14, 17, something like that. Like, you gotta show them the prime numbers. You know, you don't want to be showing them the thousands of like, come on.
But certainly not exact. So primes essentially occur at random.
We learned that already.
But of all the primes, 37 has reason to stand out.
Design you feel in every detail. Technology as
If we were to find the prime factors of every number, we would see that 2 is the smallest prime factor for exactly half of them, all of the even numbers. And
now look at this. Okay, so this is a little bit more simplified right here. It's starting to make a little bit more sense, but we're gonna see as it goes on. But as of right now, we haven't seen anything really simplified and broken down just yet, like on a scale of prime factor numbers. You get what I'm saying? Even the smallest prime factor numbers is a lot different from what we've been seeing so far.
3 is the smallest prime factor for a sixth of all numbers, anything that's divisible by 3 but not by 2, and so on. As we pick larger and larger primes, they form the smallest prime factor for fewer and fewer integers. But what if we track the second smallest prime factor of each number? Well, first we have 3, which is the second prime factor of a number, only when the number is divisible by both 2 and 3, or
What
divisible
is
by
this
6.
about, yo?
So 1/6 of all numbers.
If anyone understands this, please comment how you understand this and make sense of this in the comment section, so I could understand this better, because as I'm watching this right now, it's kind of hard to understand this better. I'm kind of getting hungry. I kind of want to go eat something right now real quick. But I don't know what it is I'm going to go eat. Is it Chili's? Is it Chick-fil-A? Is it Wendy's? Is it Burger King or McDonald's? Olive Garden? Which one exactly do I want to eat? But I'm not asking y'all what do I want to eat. I'm asking y'all, if y'all understand any of this, please put it in the comment section. I want to see even a mathematician that knows math. See if he understands any of this, or she understands any of this, because I don't think that even they would understand this, because this is a incredibly complex theory or complex situation involving numbers. I want to see if anybody can understand what this video is saying about this kind of stuff. It's so interesting to me if y'all do understand. Would Albert Einstein even be able to understand something like this?
Numbers have a second prime factor of 3. And as we keep going, which number will end up at the balancing point? This is the median second prime factor of all numbers from 1 all the way up to a Google and off to infinity. Would you believe that number is 37?
Oh.
Let's take a look at 5. 5 is the second prime factor only when a number is divisible by 5 and 3, but not 2. Or 5 and 2, but not.
Well, 5 times 3 is 15, so that must be another prime, right? And 2 times 5, what that is? 2 times 3 is 6. And 6 times 5 is 30. Yep, 30. So is 30 and 15 also a prime number? That is something to think about if we're talking about it right now as we're talking about it. Because if 15 and 30 would actually be a prime number, wouldn't it be easily understood of how to make prime numbers and how to understand what the prime numbers are?
3. In the first case, a number divisible by 5 and 3 means it's divisible by 15, so that's 1/15 of all numbers. But it also can't be divisible by 2, so half of 1/15 is a 30th of all numbers. In the second case, a number divisible by 5 and 2 means it's divisible by 10, but it cannot be divisible by 3, so we're left with 1/10 times 2/3 equals 1/15 of all numbers. Adding up these two cases, we get that.
So you see how they got the 1/15, the 1/2, 1/30, and the 1/10, 2/3, 1/15. And then you gotta add up the 1/30 plus the 1/15, so you're gonna end up getting like a 2/45. So is that the main prime number that we've been looking for this whole time now? Is 2/45?
1/10 of all numbers have 5 as their second prime factor. And we can repeat this for the next prime, 7. Just take each of these cases and add them up to get that 1/15 of all integers have a second.
So you would take 4 1/5 plus 2 over 1/5. Wait. So you would take 4, 2, 1, and 7 over 1/5s, and it would come to a 1/15, 1/15 of all numbers equal prime numbers, and is a prime factor to the second smallest prime number. Hold up here. Now this is really starting to make sense. This is really starting to be able to understand exactly what is going on, but at the same time not understand exactly what's going on at all.
Prime factor of 7, and so on. Keeping a running total, we quickly approach a balancing point for the second prime factor across all integers.
What's up with them little numbers going next to the big numbers for us? It's just getting smaller and smaller and smaller. Like what is even up with that? Why is that even something that's happening?
And then we reach it. So the median second prime factor of all numbers is 37. Half of numbers have a second prime factor of 37 or less. There are other remarkable qualities about 37 as a prime. It's an irregular prime, a Cuban prime, a lucky prime, a sexy prime, a permutable prime, a Padovan prime, and at this point mathematicians might.
It seems like it's a smart prime. It's the very last prime. It's the very one that a lot of people choose whenever they choosing between random prime numbers or random numbers. Is the main number that a lot of people are choosing, 37, which is a crazy number to be choosing from, right? But it does make sense in terms if you do it. If you say, all right, give me a number between 1 and 10, I bet you most people would say 3 or 7 or 7 or 3. You know, I would just think that because that is so odd of a number, right?
Just be making up types of primes.
37's identity as a prime number is so strong that the same day I first learned the number 37, I learned it was prime. This was one of my first books as a toddler. It teaches you every number from 1 to 100 with a short story or fun fact for each. So for 26, that's how many letters in the alphabet, or for 30, they give the days of September, or for 52, that's how many cards are in a deck. Except 37.
Oh snap! I thought for sure there wasn't gonna be no page up in no book about no 37. I thought for sure before we had seen that, before she opened up that book, I thought for sure we wasn't about to see that again. You know, because what could there possibly be about a 37? Think about it. like someday, boy, that is crazy. What is up with that 37?
It's a prime number. Nothing goes into it. Someday, you'll understand. I did not like that. I understood every other number, so I also wanted to understand 37. So that number has nagged me ever since, and now this video is being made some 20 years later.
With Verizon, when you bundle mobile and home internet, you save $15 a month and can get the entertainment you love included.
Not convinced yet?
If you take a number that is a multiple of 37 already, like 1369, that's 37 squared, and then you reverse it.
Okay. We don't even know him. How do we know he is telling the truth? We understand about the book. I think the book thing is the truth. But here we go with this guy just rambling about numbers. How we know he rambling about numbers and telling the truth about it? How we know is his theory is the right theory about the number 37.
And then you stick a 0 in between every digit, then that number is a multiple of 37. And I literally spent the next month on the bus trying to prove that fact, which I finally did. Just rattle off a 6-digit number. Tell me any 6-digit number.
4132625.
And it's not divisible by 37. So how did I figure that out? There's a trick for that.
Is this your party trick that you can bring out?
Surprisingly, it doesn't impress as many people as you would think. I think it should impress everybody.
But there's also a practical reason 37 is...
Seem a little bit nerdy, I guess. Seem a little bit nerdy to wonder what the 37 stand for, I guess. But at the same time, it's freaking interesting. Might seem a little nerdy, here and there, but it's interesting to know what this number means. Like, why do so many people choose it? Why does it come up in certain situations? Why does 37 even exist? Number 37. It don't make no sense.
Is an important number for humanity. Say you're faced with a choice that is both immediate and final, like whether to rent the apartment you've just toured, or whether to accept a job offer you received. Or it can be as small as whether to stop at the next gas station on a road trip. These are all problems where you can't assess all the options at once, and then decide. With each option you encounter, you need to decide whether to accept it or reject it forever, and see what comes next. In these scenarios, it feels impossible to make the best choice. If you select too early, you'll probably never even see the best option. But if you select too late,
Well, I think that humans do that a good bit, like between deciding to go to the mall or go and visit their family, or going to work that day or going to do something else. I think that humans decipher long and they can't reach a decision right away, like talking about like it kind of takes a human probably longer to reach a decision right away of what exactly they want to do in the moment. You get what I'm saying?
well, then you probably rejected the best option already. So your best bet is somewhere in the middle. There you know at least some information from the options you've seen, and you have some choice to select or pass. But how do you know exactly when to decide? The optimal strategy looks like this. First, you need to see some options and reject them automatically, just to learn what's out there. And then, at a certain stopping point S, you need to stop rejecting them and start evaluating whether an option is the best you've seen so far. If it is, then select it.
It kind of makes sense in the terms of like if you're walking through a mall and you're looking at stores where you think you might like to go get your clothes and stuff like that, you know, and then you walk by a store like you're walking by all these stores and you're seeing nice clothes in them, but you're saying, well, I don't really want to go in that store today. I don't really want to go in that one either. But you see one store, you pass by one store, and it's like, oh, check that out in there. And it's like, maybe that'd look pretty cool on me. And it's like, you go up in that store, and that's the one that you chose. So out of all those stores in the mall that have clothes and everything, you chose that one store that specifically that you think is going to make you look cool and everything with the clothes and everything. And you go in that store and you pick it out, and you like, dang, this look cool on me and everything like that. And next thing you know, you like that store, right? Well, it's the same thing of choosing gas stations too, you know, like one gas station you pass next to might look a little run down and might look like a place where you don't want to really go get your gas. So you go to a better looking gas station that look like it was built good, that look like it has real good employees and it's replicable and all that. So you go to that gas station to get your gas, you know, and everything. So it just makes sense.
But when should that stopping point be? We need to work out which stopping point maximizes our chances of picking the best option. We can calculate these chances. For each spot, find the probability that the best option is located there times the probability we get there from stopping point S. Then add these probabilities up across every spot. Now, the chance of the best option being in any spot.
Now you see, that's a little bit too much for me. You see, enough for me would just be walking, like I said, giving the example of just walking through the mall looking for the stores. And you know, you might pass by a bunch of stores that you would like to go into, but it's just something about them stores that you say, I ain't going to that store today. But then you find that one store, they have them shoes that you've been looking for, they have that shirt that you've been wanting to buy ever since you've seen it somewhere. They have them pants that you really want to go with the shoes and shirt. And it's like you got it. You go in that store and you get that, you know, and so you done pick that store. It's not all about like, oh, seeing 3 different stores that you see stuff that you might like in them, and then you choose one out of the 3, right? Because if you walking through the mall, you could go in that first store that you see, like after passing up so many different clothes stores in the mall, you could go in the one that you really like, and then go in another one that you really like, and then another one. So it's not about always choosing 3. Choosing 1 out of 3, because if you go in the mall, you could easily choose, you know, 3 stores in a row to go to and pick out your stuff. You get what I'm saying? Like yeah, you could pass up a bunch of stores on the way to that first store that you will walk into and buy stuff, but it don't change the fact that you might walk into 3 different stores and buy stuff. You know, it don't change that. You know, everything's random.
Spot is just random. If there are n options in total, it's 1 over n. But it's a little harder to find the chances of getting to each spot. Say the best option is in the next spot after S plus 1. What are the chances we get there? Well, since this is the next spot over from the stopping point, we have a 100% chance of getting there, so we're guaranteed to visit it and select it. But if the true best option is in spot S plus 2, well, there's a small chance we'll miss it. If the best of all the previous options is sitting in spot S plus 1, we would just pick that and stop looking before reaching S plus 2. There's a
and that's something else. So even though in the mall, whenever you walk in that first store and buy the clothes that you want, you might come to another store in the mall where you walking and you're looking in the store and you're seeing what they got and everything, and it's like you gotta stop because you're like, oh, that's even cooler right there. That would even look even better for what I'm going through later, and then it's like you realize that they had something better than what you first seen. So you go buy those sets of whatever clothes that is. You get what I'm saying? So it's like, even though your first opinion of the clothes that you first see is like like in the beginning might be your best opinion in the beginning to buy those things, but then you run across some other clothes in another store later, and it's like, dang, that looks even way better than the clothes I got earlier, so let me get this too so I could wear this instead. So it's like, even though you made the best decision that you could make in the beginning, now you're even making a better decision because you're buying stuff that you even like more. You get what I'm saying? It does make sense.
1 in s plus 1 chance of this happening. So the chances we do get to spot s plus 2 to pick the true best option is 1 minus that, or s over s plus 1. This same calculation...
You know, that's a lot of different letters to be going off of, you know, instead of just simply breaking it down and simply explaining everything like you know how someone should do is different. It's definitely different to see a bunch of letters and number forms and all those type of things, because that ain't really explaining nothing to me, because I don't learn that way. I learn by somebody explaining something simply to me, breaking it down simply to me in a way that I could understand, in a way that relates to my life. You get what I'm saying? Because numbers, like, I mean, not numbers, but letters that's trying to be numbers, that don't have no relevant thing, you know, going on.
That one of the first S options must have been the best of the total n-1 options we've seen. In total, this gives us the expression 1 over n times 1 plus s over s plus 1 plus s over s plus 2.
Okay, so if anybody could understand them numbers, let me know. What I've learned so far from about this whole number thing here, about 37, okay, is that some people choose it because it's an incredibly random number that has two incredibly random numbers in it, 3 and 7. Both of those are random. But at the same time, people aren't choosing numbers as randomly when choosing random numbers, when choosing numbers as 5, 1, and 10 and 9 and those type of things. So it makes sense of why 3 and 7 is so connected in that rare number that a lot of people are choosing, right? Because, well, I mean, just because, basically. It's kind of easy to understand. You know, trying to go off of these S's and N's and P's and all this kind of stuff, that is not simplified. That's not a simple way of talking about it, you know. I think a simple way of talking about it would be to talk about it like I talked about going into a mall earlier and doing what I said from earlier. But a lot of this other stuff is just not making too much sense, and it's like you almost would have to be a rocket scientist to be able to understand it. So thank y'all for watching.